So welcome guys. Today we're going to learn about methods of purification. In the methods of purification lesson, there would be four subtopics which we would learn about: filtration, crystallization, distillation, and fractional distillation. Let's get an introduction about what is this methods of purification is. So this methods of purification is that you would have like a solid, which means the solute that would dissolve in a solvent. Now guys, the universal solvent in this entire universe or this entire world is water, and when something, a solute, dissolved in a solvent, it forms a solution. So this separation techniques is all about how do we extract a particular thing from a solution. It would be either a solution, either the solute, either the solvent, or either a solvent from many solvents which are miscible. Let's move on further. The first we would learn is filtration. This is the technique used to separate an insoluble solid from a liquid. The experimental procedure is fold a piece of filter paper and place it into a filter funnel. Wet the filter paper. Pour the mixture into the filter funnel. Allow the liquid. It could be a salt solution, sugar solution, or any solution to pass through as the filtrate. The insoluble solid, which could be sand or either pebbles or whatever it is, would remain on the filter paper as residue. This is an example of filtration. You could see the filter paper folded and put on the filter funnel, and the solvent added where there's a residue, and the filtrate which is in the beaker. We then get uses of filtration in our exams. If they asked uses of filtration, you better write these two: removal of solid impurities from water in treatment works, and separation of penicillin from yeast. Crystallization, the second subtopic. Crystallization is used to separate pure solids in the form of crystals from the impurities suspended in the solution. The experimental procedure is: the impure solid is dissolved in the solvent through a process called dissolution and heated until the salt dissolves. The salt solution is filtered, leaving the solid impurities behind. The salt solution is heated until a saturated solution is formed. The saturated solution is cooled to form crystals that can be dried on a filter paper. Uses of crystallization process is obtaining pure sugar, making pure silicon used in computer chips, or even purification of antibiotics. Now this is guys the procedure of crystallization. You can take a clear picture of what I said by referring to this diagram. Distillation. Here guys, distillation means the simple distillation. This process is used to obtain a pure liquid, which means the solvent, from a solution of a solid, which is the solute. The experimental procedure is: the water tap is turned on to ensure a circulation of water around the condenser. You could even say Liebig condenser. The solution is heated in the flask. Upon boiling, the thermometer reads a constant temperature and droplets of liquid are collected in the beaker. Discard the first few drops of liquid collected. Collect the desired liquid or the solvent as the distillate in the beaker until the temperature starts to rise again. Turn off the flame and allow the apparatus to cool down. That's the procedure. And here's a picture of what I said: the Liebig condenser, the cooling water, and the flask with the boiling solution, a Bunsen burner to supply heat, and the receiver flask. Now make sure guys, there would be questions in the exam about an error in like they would give the diagram and ask you about an error. Probably the error would be either the point where the thermometer bulb is kept, or either the point, or either the where the receiver flask is closed with the bung. If the receiver flask is closed with the bung, that would be wrong, because pressure could build up inside the receiver flask and cause the flask to blast. So make sure to remove the bung. And the thermometer bulb should be where the Liebig condenser starts by leaving the flask. Next, we would be observing fractional distillation, which is an advanced method of simple distillation. The fractional distillation is the separation of a mixture of miscible liquids with different boiling points that can be done through fractional distillation. Experimental procedure. The water tap is first turned on to ensure circulation of water around the condenser. The miscible liquids are heated in a flask. Upon boiling of the first liquid, thermometer reads a constant temperature and droplets of liquid are collected in the beaker. Discard the first few drops of liquid collected. Collect the desired liquid in the beaker until the temperature starts to rise again. Repeat the distillation process and collect the second liquid and any other liquids. When the next constant temperature is reached, then similarly discard the first few drops of liquid collected, and after all the desired distillates have been collected, turn off the flame and allow the apparatus to cool down before the water tap is turned off. Now this is a picture of fractional distillation where you would see fractionating column, a thermometer, water outlet same as a Liebig condenser in the simple distillation, and the receiver flask. Now friends, this fractional column or these glass beads which are in the fractionating tower means that there's a function for the fractionating column where the glass beads are or fractionating tower. Its function is that it drips back the other liquid while the other liquid is boiling off. When one liquid is boiling off, it helps in dripping back the other liquid, as it does not allow two liquids to evaporate off at the same time, and makes sure that the receiver flask receives only one liquid per time. Got it, my friends? Okay. Now that's the end of our lesson. Before that, uses of fractional distillation, separation of liquid air into oxygen, nitrogen and other useful gases, separation of crude oil into petrol, kerosene and other useful components of crude oil, separation of fermented liquor into ethanol and water. Okay guys, those are some uses of fractional distillation, and make sure to remember these as you go to the exam. Now the summary is that we learned about filtration, which is the separation of an insoluble solute from a solution. Crystallization is the obtaining of the substances from a solution. Got it guys? By crystallizing the solute. Distillation is the separation of the solute from the solution. Sorry, not the solute, the solvent. Okay, fractional distillation is obtaining a solvent from a variety of miscible liquids. Got it guys? Okay, so that's the end of my video guys. So thanks for watching, and if this video was of any help to you, give us a thumbs up and leave a comment down below in the comment chat box, and make sure to subscribe my video. Thanks for watching. Like, share and subscribe.